Data Science Actuaries Shaping the Future. This is a panel discussion. I'd like to open up by saying this is Amanda Aiken's presentation. Unfortunately, she's not able to attend today, so I'm a stand-in. So if it doesn't work well, blame me. But when it does work well, please praise Amanda. So we're going to spend about 20 minutes today having a chat with Jessica, who's here, and three panelists who will come on the screen shortly. They will introduce themselves. We will talk about, I'll give a very brief introduction to the data science application subject to give you some flavor of what it is. But the guts of this is about 20 minutes where we're asking these fellows to explain to us how data science application subject has helped them in the workforce. We invite, as ever, you guys to use the electronic app to submit questions. Please do that as we go through the discussion. And finally, at the end, I'll give you a pointer on where you can learn some more. So, these are Amanda's words, so I hope I don't mess them up too much. In an era where data reigns supreme, data science actuaries aren't just crunching numbers, they're shaping the future. With these four fellows today, are going to describe how these data science tools have been implemented in the trenches of actuarial work, and they will unpack the tangible benefits that data science brings to the actuarial table. So I should use this to go forward. Right. I'm going to meet our panel. I'll start off with Jessica, who should introduce herself.
Hello, I'm Jessica. I'm currently a consultant at Taylor Fry. And I've had around 3.5 years of experience, mainly working with compensation schemes and government clients. So the main types of projects I've been involved in include workers' compensation valuations, as well as government analytics projects, such as a microsimulation and demand model. I studied data science applications at the end of 2022.
Okay, thank you. Pass over to Jin, who's online.
Hello, everyone. Thanks, Mike. Hi, everyone. My name is Jin. It's a pleasure to be here today. I am a data science actuary working in the life insurance space. I am an alumni as well from the data science application subjects, and I'm very excited today to join this panel to discuss some of the data science AI-related topics with you.
Thank you. Michaela?
Hi everyone, my name is Michaela Bean. I am a senior consultant working at Ernst & Young EY as part of our Health and Human Services team within Actuarial Services. Within our team, we do a range of advanced modelling and analytical capabilities for a range of government agencies, both at the state and federal level. Throughout my 4 years at EY, roughly, I've been involved in a range of different projects, including microsimulation and demand modelling, projects relating to health funding, and more recently relating to well-being measurement.
Thank you. And finally, Alan?
Yeah, thank you. Hi, everyone. My name is Alan. I'm a team lead within the predictive modelling team in Group Actuarial at IAG. I've been at IAG for 6 years now. And I've got a background in GI and data science, qualified a few years ago now. My team specializes in automating the reserving process, and we run a platform which services all the short tail valuations across the organization. So basically we use data science techniques to enhance the actuarial valuation process.
Thank you. So before we enter the 20-minute discussion, I'm just going to spend a couple of minutes talking about the data science applications subject that we've been running for about 3 or more years. The purpose of the subject is to teach the candidates how to apply a range of data science skills, such as neural networks, natural language processing, unsupervised learning, and optimization techniques, and using professional judgment to solve a variety of complex and challenging business problems. These business problems are from a wide variety of industries, not just the typical financial services. A successful candidate, when it's managed to go through that and pass the subject, would be able to demonstrate how to assess the impact of complex business environments on all stages of their data science project, perform data science using a variety of tools and techniques to successfully solve realistic business problems, and finally, be able to contribute to the successful implementation of a data-driven change in an organization. So now we'll go to the Q&A session. We're going to have 4 themes that we'll go through with the panelists, and then we'll open it up to the floor. My first question is to Michaela. Why did you choose to study data science applications as your final fellowship subject?
Thanks, Mike. So I studied the data science applications course back in late 2022, and that was the last subject that I studied to finish off my qualification. I think what interested me most about this subject was that it allowed me to continue developing a lot of the skills that had already been introduced in some of the prior actuarial studies. So I did study some data science courses as part of my Part 1s and Part 2s throughout the way. But I think the thing that the Part 3 data science application course really interested me for was some of those more complex algorithms that Mike mentioned before around neural networks and natural language processing, and more detailed unsupervised learning, which were things that I hadn't necessarily learnt before, but had heard people in my team using throughout some projects and was very interested to get some exposure to those, to learn more about them. I think this subject is extremely practical and hands-on, which is something that also really influenced my decision to choose it. The assignment is a large part of the subject, but it's also extremely practical and interesting, and I learned so many things. I think our assignment was talking about predicting property prices, which in Sydney, which definitely felt like a very relevant area of interest that was very interesting to me. And I think as well, as Mike mentioned before, the focus on business soft skills around the consideration of ethics and data science work, as well as learning how to communicate model results to a non-technical audience, those are all things which I saw as extremely valuable skills that I wanted to learn and continue developing to allow me to progress well throughout my career.
Great, thanks for that. This is a question to Jess. What did you enjoy most about studying the subject?
Yep. So personally, I enjoyed the assignment. I think it was a great opportunity to put the data science techniques that we learned into practice to solve a real-world business problem. So as Michaela mentioned, we studied it in the same semester, but our task was to address the property market trend for properties to sell for more than they're advertised. So we had to build a model in Python in order to estimate the price ranges that properties are likely to sell within, given the information that's available on the listing. The data that we were given was also real and taken directly from Domain, which meant that all the data cleaning we did was realistic, and our analysis also produced genuine insights. I liked how the assignment allowed us to go through the whole modeling process, from the initial domain research to the exploratory data analysis, data prep, and modeling. And it was also set out in a way that allowed us to apply many of the techniques that we learned, such as natural language processing, neural networks, and unsupervised learning. So overall, I think that the data science applications assignment was quite hands-on, and so I learned a lot. Although it was very time-consuming, it was also well-designed as well. And I think there's really nothing like applying your theory to an actual problem for gaining useful experience and practical knowledge.
Great, thank you. How long did it take you to do your assignment?
Oh, I didn't keep count, but it was a very long time.
Okay.
Many hours per day, yeah.
Okay. Great. The next theme we're going to discuss is on applications in the workplace. Again, this question's to you again, Jess.
Yep.
What data science techniques or other learnings from DSA have you applied in your work?
Yep. So I think one of the nice things about DSA is that we do get to learn about those technical data science methods, but there's also learnings beyond that as well, which I think are quite important, and that includes things such as data privacy and security, ethics, and communication. And yeah, Michaela has mentioned that previously as well as reasons why she wanted to study the subject. But first off, I'll probably just give an example of how I've applied those data science techniques at work. So I've been involved in a few government projects in the past where we had to build a lot of GLMs. And what we learned in DSA is quite relevant here in that it teaches us the core principles of building good models, as well as how to check that they're unbiased and a good fit. We also get a lot of experience in building and evaluating models through the assignment. And even though these aren't necessarily the GOMs which I do at work, the same overarching skills and principles still apply as they do to any type of model that you might build. As for a key learning outside of these technical skills, I think one is related to communicating technical concepts to a non-technical audience. This is critical to be an effective consultant, as I think that good technical work would be wasted if we can't, if the client can't understand or translate it into actionable insights. DSA has helped in that it teaches us the principles of good communication, and it also provides us with many opportunities to practice communicating to non-technical audiences, both in written form through the exam questions, as well as verbally through the assignment presentation. And finally, another area that is vital in consulting is data security and privacy. So we're often reminded of its importance at work and follow processes to ensure that data is secure. For example, in some government client projects that I've worked on, we've either used separate laptops or worked on a virtual machine in order to ensure that the data doesn't leave the system. I think DSA has helped me to build a more holistic perspective on data security and privacy. The subject explores the fundamentals of why it's important, as well as good practices to follow. And I think ultimately this has influenced me to develop take a more informed and mindful approach at work.
Right, thank you.
Yeah.
This is a question that's going to all four panelists. Can you share a specific project or case study where data science positively impacted your actuarial analysis of decision-making processes? This goes to Jin to begin with.
Thanks, Mike. There are a few use cases I've come across, and the one that I'm going to share today involves using a language model to unlock unstructured data, and particularly free text and natural language data. So just for context, in one of the companies that I've worked for in the past, after we launched a new product, we came to realize that we've taken on some occupations which were meant to be the client occupations per the advisor guide. And we needed to project cash flows at a policy level for various purposes in the actuarial team. And these cash flows are rated by occupations. For example, your premiums are rated differently by occupation, and so with your claims cash flows. And if an occupation for policy is of the client occupation, then there would effectively be no loading assigned to that policy. So one workaround we found is to use a language model. It's not even a large language model. It's a small open source language model called BERT. It's a Google model which we've used to map the client occupation into the most similar accepted occupation. And we found that the results of these kind of matching was quite reasonable. Just upon inspections of the output, some examples that I'm going to give was, I believe, a dancer was mapped to a dancing instructor, which was an accepted occupation, and a tattooist was mapped to a dermatologist, and a stunt person, like people who do stunts, was mapped to a lines person, which I found quite amusing. And using the same language model, we were able to undertake some other natural language related tasks as well. For example, for free text claims courses, we were able to map them into more standard libraries of claims courses. And also when we were trying to source data from different source systems, for example, the day of the event may be named differently across different source systems. It could be named to incident date, event date, day of incident. But this kind of model would help us identify they are the same field, and it would help us recognize that and map them into a common data model.
Thank you very much. Same question to Alan.
Yeah, cool. Yeah, I guess similar to Jin, I also was involved in a project several years ago. Basically, I guess the context was to help determine who is at fault in a motor vehicle claims. I guess the background to this was that, I guess, reviewing the claims and determining the fault rating, whether it's our insured at fault or the third party at fault, used to be a very manual process where claim staff would need to come in and kind of review the claim. So I guess our goal was to develop some sort of model or algorithm in order to, I guess, determine that fault rating. So what we did was we took the claim description field as well as a few other kind of claim related fields and used natural language processing on them, I guess, to determine the final fault rating. I actually found it's really similar to some of the methods applied in the data science assignment. So this was a few years before I did the assignment, but when I was doing the assignment, I felt it was really relevant, I guess, because they use, the techniques such as lemmatization, fuzzy text matching, TF-IDF, and I thought it's really interesting that these are all kind of techniques that were taught in the course. I guess the end outcome of the model was that we could really speed up the decision making for the fault rating, which used to, as I said before, take a manual review, so that the claim could be moved quicker onto the triaging or the kind of allocation process, rather than kind of being stuck on that initial fault rating. So yeah, I guess that was, a key project where I could use data science.
Thank you, Alan. Michaela?
So I'm going to talk about a different technique, I think, to what everyone's talked about so far. So this is an example of using clustering. K-means clustering in the workplace, and I believe it was also, similar to Alan, it was an example of a client that I'd worked for a couple of years before performing this course. So I think it was really interesting to see, I guess, to get that extra knowledge as well through learning the course. So in our example, what we had is one of the government agencies had a range of different members, and there were obviously lots of characteristics and lots of data that was collected on those members, but too many variables or columns in the data set, you could say, in order to easily segment their cohort, their database into some sensible cohorts for policy purposes. And I think ultimately what we ended up doing was building a clustering algorithm to help the client try and understand 5 to 6 key different cohorts of members that they have in their base at the moment, from about maybe 200 to 300 variables of information that we had on them. And as a result, what we were able to do is get a sense of who those people are, be able to identify who's falling into each cohort, but then be able to test the impact of what certain policy decisions may have had on each of the different groups of members, but also be able to track the behavior of these members over time, how their health, how their living status, lots of things like that. Demographics may have been changing over time. So I think it was able to provide that agency with a view on their member base that they may have been unable to otherwise obtain without some of these complex machine learning algorithms.
Great, thank you. Same one to you, Jess?
Yep. So I think my experience with using data science at work is quite different to the other panelists, in that I've mainly worked on government projects where transparency is quite important. And so we've mainly used data science techniques as a supporting tool rather than as part of the main model build. And this is generally because those advanced data science techniques might lead to better predictive performance, but they're often quite opaque and difficult to explain to stakeholders. So one example of a project is a peer review we did of a model built for a government client to help with the prioritizing of claims, so that vulnerable people are attended to quicker. And the model itself was relatively simple in that it involved weighting and scaling variables to output a vulnerability score. And the client actually favored this transparent approach because it was important for them to not only understand who was predicted to be vulnerable, but also why. So as part of our review, we used GBMs as a supplementary tool in order to find some additional variables that could help better predict vulnerability. And as part of our review, we were able to find a few which made sense to include, as well as improve the existing model's performance. as the client kind of wanted to keep that simple structure. So this is just one example of a project where the data science techniques were used not in the main model build, but to find additional insights. And I think it's a pretty similar use case for some other government projects I've worked on as well.
Cool. Thank you very much. The next section we're going to talk about is the challenges of using data science. The first question goes to Alan. How do you balance long-established actuarial methods with innovative data science approaches in your work?
Yeah, thanks. I mean, I think this is something I constantly am challenged with in my role. I guess, as I was saying before, my role is to kind of bring data science approaches and kind of automation into the kind of long-established reserving process. I think when it comes to balancing the two, it ultimately comes down to the right approach for the task at hand, and you often need to consider aspects such as what data you have available, the needs of your stakeholders, as well as the time and resourcing constraints. I guess the biggest challenge that I find is often just the data available, particularly in claims reserving. We're often working with a data set which is pretty limited when it comes to covariates, and in particular, certain lines of business can be pretty sparse when it comes to the data available, such as long tail classes, for example. So in this situation, it wouldn't really make sense to, say, use like a neural network or really kind of advanced or really complicated modeling, as obviously the results aren't going to be very reliable. So in these cases, we usually opt for a much more simpler approach that oftentimes may be perceived as like less advanced, but I guess the key thing we're going for here is kind of accuracy and in consideration of the data that we have available. I think the other thing to consider is kind of the needs of your stakeholders. So I guess I found in most cases in reserving, people generally want to be able to explain how the results are, and generally they want to be able to say that it's in line with their expectations based on their understanding of the data. So I mean, if the results can be communicated, simply with a simpler approach, such as like a GLM, for example, then and it gives them greater confidence due to the, I guess, greater transparency of the model. They can easily see how the model's working compared to, say, a neural network, which is more of a black box. Oh, sorry, my light's just gone up. Then I don't see there's any reason to use a more complicated model just for the sake of it. So I guess that's where I'd say it's the two kind of key aspects, is the data you have available and also the needs of your stakeholders.
Okay, thank you. The next question is to Jin. What ethical considerations do you think are crucial when applying data science techniques in actuarial work?
Thanks, Mike. So I think ethics is definitely a very big topic in this space. I think just touch on some of the considerations earlier, with respect to data security and privacy. And I think the Australian government actually has published some guiding principles on the use of AI and from an ethics perspective, and also the DSA subject touches on some of these as well. I believe they've published 8 guiding principles. I'm not going to go through each one of them, but some of the key ones include fairness, just making sure that your predictive modeling is not introducing unnecessary bias or discriminative impact. And also just making sure that the model is human-centered, so it ultimately creates positive human impact, and perhaps not only that, but also society impact from an ESG perspective. And what's, I think, most relevant for actuaries is making sure that the output of these models are explainable and interpretable, as Alan touched on earlier. I think in practice, one way to ensure that these principles are observed is to create governance around these. So one way is to perhaps construct some questions under each of these principles and ask these questions to the accountable persons implementing some of these models in practice, so that they are documenting around these principles prior to implementing some of these models, and and not only for models going into production, but perhaps making sure that these are considered when they are building a proof of concept as well.
Okay. I'm going to add in a question to all the panelists. You're all using lots of words that I'm pretty much unfamiliar with. You use them very naturally. How do you communicate some of these ideas to your managers and your directors? Is it a simple process? Do they all understand the words that you use, or do you use some other techniques to explain what you're doing? I'll throw it to Jess.
Yeah, that's a good question. So I guess generally, if it is like I'm working on a project and we use these advanced techniques, yeah, generally the people on my team would know what I'm talking about as they're like supervising me or like kind of leading the project. But in terms of like maybe explaining it to a client who might not have that kind of technical background, I think it's most important to kind of, I guess, know the client's background and what they're interested in so that you can kind of focus on those key aspects, like, for example, key assumptions, inputs, and outputs, rather than go into those complicated technical details that might make them confused and like lose confidence in your work. And in terms of like explaining things a bit easier, it's also helpful to use visual aids where possible.
Okay.
I think that people tend to kind of follow those kinds of representations a lot easier and it sticks to their mind. So things like a flow chart to show the process of something, or like a diagram showing like key assumptions, or like how the inputs flow into the outputs. Yeah, things like that.
Would anybody else like to have a stab at that question? Alan?
Yeah, sure. I mean, as much as I think all of us can kind of agree, like as much as we like to show off some of our technical skills and things, like often cases that's probably not the most important aspect of the piece of work. I think more focusing on what are the key takeaways and some of the tangible benefits that your stakeholder can kind of take away from all the analysis is something you should focus on, less so kind of the technical details. I mean, of course, you can kind of explain and walk them through it in kind of easy to understand language if they do require that. But I find oftentimes just more focusing on kind of the results and kind of what are the insights that you can derive from the analysis tends to help.
Cool. Okay. Anybody else want to add to that one, or do you think it's covered?
I'm happy to add something,
Yes,
Mike. I just wanted to touch on a point that Jess raised before around, with some clients that may be from a non-technical audience, about how sometimes the results may not be the primary output that's needed for the audience. It might also be the fact that they need you to reassure them that you've done your checks, and I guess what sort of sense checks, reasonableness checks, things that have been performed over these model outputs to give them confidence that the results actually show something that's meaningful. And I think, as Jess mentioned, for government clients as well, which is the area that I work in, like with the clustering example I gave before, it was about actually critically assessing with the client, like, does it make sense that that all of these people will fall into this cluster, or are there people that are maybe falling into this cluster that shouldn't have, and how can we change that, and what changes do we need to make? So I think that nature of giving confidence as well to your stakeholders or your managers, in terms of not just relying on the results, but really critically thinking about whether they're correct, is a very important part of the piece of the puzzle.
Cool, thank you. The final question for this section is on the future. How do you stay updated with the latest developments in data science and its applications in the actuarial field? And that one's to Alan to begin with.
Yeah, sure. I mean, I guess with any kind of field of interest, I mean, staying up to date could involve, reading news articles about the topic, attending kind of seminars and events such as this one. Looking at research papers. I think also like there's a lot of YouTube channels, I think, dedicated to certain kind of topics. So I mean, like data science and artificial intelligence is a pretty big one these days. So I think you can probably find a few channels there. I think the main thing is just thinking about ways you can kind of take what you've learned and picked up from various sources and kind of apply them to your next piece of modeling. I think obviously it needs to be balanced with, I guess, not just blindly chucking on a neural network onto anything, but I guess balancing that with the needs of your stakeholders and I guess the constraints of the data.
Okay, thank you. Jin, would you like to add to that one?
Yeah, thanks, Mike. I think just to add to what Alan has said, I think I can only speak to my personal experience to stay up to date with these latest developments. I think one way for me is to subscribe to a number of podcasts, and the way that I used to find these podcasts is simply do a Google search on best data science podcasts, and you just go to like the top 3 links, and then you just subscribe to the common ones recommended by these links. And same way you can use to subscribe to some of the newsletters. And I think one podcast I would recommend is called the Super Data Science Podcast. It updates weekly, and I believe in one of the episodes, one of the Australian actuaries was invited to speak on the topic of classification model as well. I could be wrong. And another way, I think, for me is to be part of a community. For example, I'm part of this working group with the Institute, YDoc, which we meet regularly just to exchange ideas and discuss our views on some of these emerging technology developments. And in a similar fashion, at work, you could set up a forum where you invite people from different parts of the business to come and exchange ideas. And I think just to add to Alan's comment around YouTube videos, if you want to get more hands-on, obviously you can, just go on YouTube and search for how do you do X, Y, Z, and there will be plenty of open source, tutorial-like clips out there just on, different topics.
Cool. Thank you. That's the end of the prepared questions. So now we're in the session where we get the unprepared questions. We've had 3 come through from the floor, and to encourage others to add. The first one from Stephen Dieppe. Data science is a crowded space nowadays. What do you think are the competitive advantages of actuaries in data science relative to data scientists who are perceived as well-regarded technical experts in this area? What extra do we bring? So I'll ask Jessica to have a go at that one.
Yeah, I think that is a good question. I think, actuaries, we do have like that mathematical and technical skills that allow us to also do data science. But I think, especially in like maybe the more traditional work that we might get experience in, or like things that were taught in our studies, I think judgment is one very important thing that we learn, like kind of knowing how to like sense check whether the results of the model are correct, and also like how does it impact like the business or like consumer outcomes and things like that. We kind of have a bit more of that insight and considerations into those generally from what we're taught and our background. So I think that's probably something that we can offer additional to like people who specialize in data science.
Yeah. Would any of the panelists online want to add anything to that, or?
Yeah, sure. I can add to that. Yeah, I guess adding to what Jess was saying. Yeah, we're often trained to think about the domain and like the context of the problem a lot. I think we have a strong kind of foundation in working with different contexts and always considering kind of various aspects, not just purely relying on the data. Oftentimes, I guess we're often trained that sometimes just the data is not kind of the end all be all. There's an additional layer of kind of judgment and kind of understanding of the context that can be applied on top of that. Often there's certain situations where you just don't have data at all. So that's where I think actuaries can still add a lot of value.
Cool, thank you. The next question. Regarding the model stroke algorithm to determine who is at fault for the accident, how accurate did the model end up being? Also, what would happen if the policyholder and the third party had conflicting versions of events for the accident? It's from Shiva, and that's obviously directed at somebody. So I'm trying to think who was talking about that.
Oh, I think it was Alan.
Yeah,
I think it was Alan. Yeah.
Yeah. So the first question is around the accuracy. I can't remember. It was fairly high accuracy. I forget the exact figures. I think it was close to like 85% to 90% accuracy. Obviously, there's certain cases. I think cases where there were multiple vehicles involved in a single accident, so like 3 or more, was where it generally struggled. It also struggled a bit when, because we were looking at the claim description, the claim description could either be kind of entered in by one of the claims consultants, so the person kind of picking up the call, or it's sort of like a free text field entered in by someone making a claim online. So if you lodged it online, you could enter it in yourself. So in those cases, we found the data is a lot more messy. Obviously, like it's free text, so people can just enter anything. It didn't really conform to kind of the way that a claims consultant would describe a claim. So we found those ones in particular had lower accuracy and probably we would kind of recommend it for kind of manual review. So I guess in the end, like it comes up with sort of like a confidence of like how much it thinks it's a third party at fault versus our insured at fault. And so I guess the ones kind of towards the lower end of that boundary where we weren't too sure, it's probably something we'd have flagged for like manual review. And sorry, what was the second part of that?
Second part was, and also what would happen if the policyholder and the third party had conflicting versions of events for the accident?
Yeah, I mean, in that case, I guess it may confuse the model because I mean we're looking at every kind of claim separately as if they're like separate entries. So I mean if they're like 2 different versions of the event, it may give 2 different kind of predictions of the fault rating.
Okay, thank you. I have a question here which I'm going to give to Jin. If you are a data science actuary working for, say, a life insurer, what is the difference between the types of work that you do versus the work that somebody who had done the life insurance application subject? To Jin?
Thanks, Mike. Sorry, could you perhaps repeat that question?
Yeah, so if you are a data science if you're a data science actuary working for a life insurer, what's the difference between the types of work that you do versus the types of work that somebody who studied the life insurance application subject?
I think for somebody who studies the life insurance application subject, it's more designed for a traditional actuary who performs the conventional tasks, for example, pricing, valuation, understanding capital, profit, how to report profit, or even embedded value sort of thing, and those are the traditional tasks performed by an actuary in a life insurance company. Whereas for data science actuary, I believe he or she will be able to support these functions. Just to give a few examples, I think from a tool sets perspective, based on my experience in the life insurance world, a lot of these tasks are performed in Excel, and it's repetitive. And every month, for example, if you want to report profits, somebody may need to go through, let's say, 10, 20 spreadsheets and update certain things. And at the end of the day, so at the end of these exercises, you press F9 and then you get to a number. But with some of the data science tools that you may be able to supplement this process, for example, to make it more documentable or repeatable. For example, just an exercise of opening and closing and saving Excel files that could be automated in some of the other tools, and particularly for I suppose, say for example for some of the tasks that you need to repeat every month, being able to do that in Python, for example, which is also taught by the DSA subject, would add an extra layer of documentation. And if you build it well, you could trigger this process with just one click of a button. But I'm not trying to say Python is superior to Excel. It's just to implement that kind of work to make it more efficient. So that's from tool sets perspective. And also, what are some of the new models that we're able to do? For example, if you're doing expense investigation, and you use certain attributes to set your actual assumptions, and you kind of every now and then you just update that process. You may have missed some of the important variables that may have emerged, in more recently, and you may be able to fit, let's say, a simple GLM model or GBM model to be able to identify them. Like what actuaries, where actuaries come in is to be able to select the variables that's actually important and make sure that they're explainable to some of the more senior stakeholders or non-technical audience. For example, if you pick up that people who are born on a certain day should be charged a high premium, that's certainly not compliant with kind of these ethics principles. Overall, I believe data science skills could be used to supplement the existing traditional actuarial works. And those are my thoughts.
All right. Thank you. Do you think it's worthwhile those that went through data science applications and are working in an area such as GI should try and study the GI applications, come back and study that course? Would that help? Yeah. Let's see you, Jess.
Yeah, I mean, when I was like deciding which course to do for like the final module of the fellowship program, I was kind of debating between GIA and DSA. And I guess ultimately I decided to go with DSA for a few reasons. Firstly, it is like data science is an area that I'm interested in, and I have like a bit of opportunities to do that at work. But like at that point in time, I had mainly worked on like workers' comp valuations, which is quite like GI focused. And so I felt like maybe the content in GIA, like I would eventually be able to kind of just get experience with that through work. Whereas with data science applications, I think like some of those more advanced techniques, even now I haven't really had much opportunity to do at work. And so I think it was a good opportunity to kind of learn those techniques and be able to apply them to like a real world problem.
Okay. I just go back to your chapter 2 in your DSA, domain knowledge acquisition. We have a perfect course for you if you want to come back. There's just over a minute to go. There's another question comes in. Suppose the model produced some counterintuitive results. How would you validate and communicate to the client? And I'll pass that to Michaela.
Thanks, Mike. That's a really great question, and I think it's something that often happens more often not than you think. I think, as all the panelists have pointed out, there can often be data limitations in the data that we may be using to build these models, depending on multiple factors, and therefore, I think they have the saying, not to say, garbage in, garbage out. You have to be really careful about what you're putting in your models to ensure that you are getting sensible results. But even, as you said, Mike, you could be putting in very sensible data and still be getting some counterintuitive results. I think some of the techniques that I've used in the past to sort of validate things is, I think often taking a step back to understand how those numbers look in the broader context of things. So with the clustering example I gave before, we had some counterintuitive results where we were seeing some people in one cohort which really just didn't fit in with the overall theme of what we were expecting in that segment. And I think we thankfully have developed great relationships with the clients we work with who are sometimes a bit more technical in nature, which is often helpful for us, where we're able to actually share what we're seeing and get advice from them about what they would expect to be seeing in the results. Oftentimes, I think the one benefit of our team as well, which I may not have mentioned, is we also have a broad range of staff who have worked in the health industry themselves. They may have been previously pharmacists, doctors, dentists, lots of things like that. They often bring a lot of really beneficial knowledge around what we should be seeing in the industry, which is often a very valuable insight to some of us actuaries who may not always have all the domain knowledge that we may need for some of the work that we do. So I think those are things that really help us to be able to, I think, support and ensure that we are giving results that make sense. But I think at the end of the day, I think my principle that I like to work by is I think it's best to just communicate when there are areas of uncertainty in things. There's no point trying to hide that you've built a perfect model, because I think I think it's very difficult, or it's probably actually impossible to build a perfect model. Models are just meant to be a representation of the world. So I think it's best to see what we can do to try and try and ensure that we can get the results that we can get, but also just being very, very cognizant of the fact that there will be limitations and ensuring that that's well understood.
Great, thank you very much. We have just about run out of time, and if you are interested in understanding more about data science, we do have that micro-credential on data science applications. Okay. I'd also like to announce that we're working with the Data Science Practice Committee, many members of that, to try and create a one-stop shop for data science to enable all our members to get a better handle on what's happening. So finally, I'll just leave it to say thank you very much to the questions from the floor, and thanks very much for the participation of the speakers, given their time today, and a big thanks to Amanda Aiken for setting this entire thing up. So thank you.